Before we learn about multiplying fractions, we're going to practice the skill we'll need at the end, reducing a fraction to its simplest form. Remember when we learned about writing equivalent fractions, that there are many, many ways to write the same fraction. However, we want to be able to compare our answers at the end and have everyone have the same numbers. So by convention, we're going to write fractions with the smallest numbers that we can. That's what simplest form means. It just means write it with the smallest numbers. The way that we do that is to first write all the factor pairs for each number. So factor pairs are just the numbers that multiply to be 12. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and the same thing for 30. 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, 5 times 6 is 30. Then I look through the list and I find the biggest number that's on both lists. So in this case, that's 6. Notice that 3 is also on both lists, so is 2, so is 1, but we want to pick the biggest number. This means that both 12 and 30 can be divided by 6, so I divide by 6. 12 divided by 6 is 2. 30 divided by 6 is 5. And my fraction in simplest form is 2/5. Now moving on to multiplying. The procedure for multiplying is really simple. First, we just use our axes. A negative times a positive is a negative. So I know that my answer is going to be negative. Then I just multiply across. 2 times 4 is 8. 3 times 5 is 15. What's tricky is understanding why we're allowed to multiply across when we weren't allowed to add or subtract across. But there's actually a pretty straightforward explanation for that. Let's start with our number line. So here's 0. And I'm just going to draw our negative 2/3. So here is negative 1, here's negative 1/3, here's negative 2/3. The way we've represented this so far is I would write 2 negatives, and then I would want to, if I were adding, I would want to go back the other way, back this way. Now, the reason we have to have common denominators when we're adding is that if I went 2 negative thirds this way, if I'm going to go back the other way, I would need to have thirds in order for the negatives and the positives to exactly match up. However, with multiplication, we're not going back and forth this way. We're not going back and forth in one dimension. Multiplication takes place in 2 dimensions, just like we had our little tool right here. So my 4/5 isn't going this way. My 4/5 is going up this way. 1, 2, 3, 4, 5. Here's 1, 1/5, 2/5, 3/5, 4/5. So when they interact, they're interacting here. So if I go and I draw, here's my 1 unit large box. Here's my thirds. So I've split, call that a candy bar again. I've split my candy bar into 3 pieces. And then this way, I've split my candy bar into 5 pieces. So each of those thirds got split into 5 pieces, or each of these fifths got split into 3 pieces, whichever you want to see. So what I see here is that my 1 candy bar has been split into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces. That's where this 15 comes from. I'm multiplying 3 by 5 to see how many pieces I've split my candy bar into. For the 8, I don't want that entire candy bar. Well, I do, but for the purposes of the problem, I don't. I love chocolate. I want 2 of these thirds. So I'm only going to have 2. Here's 1/3. Here's 2/3. You've seen this diagram in other classes. But I'm not taking all of those 2/3. I'm only taking 4 of the fifths. So here we are. 1, 2, 3, 4 of those fifths. So when I look here, I have this. Here, I'll color that in darker. I only have 8 of those 15 pieces, hence the 8, 15. So that's why. What you just need to remember is you need to remember that multiplication takes place in 2 dimensions on these axes, whereas addition and subtraction takes place on 1 dimension. So when you're adding and subtracting, you have to have the same units, because you're going to go this way and then you're going to go back the other way, or forward the other way. But you have to have the same units. For multiplication, because they're on different axes, you don't have to have the same units. You don't have to have the same denominator. What happens down here? We'll just put it all together. I'm going to multiply -5 times -6/10. So this is this tool, because I'm multiplying negative times negative is a positive. So I know that it's going to be positive. Now I need to multiply across the numerator and the denominator. Right now this 5 doesn't have a denominator, but I know that 5 is 5 wholes, so it's 5 over 1. So 5 times 6 is 30, 1 times 10 is 10, and then I can use my factors to reduce that. So 30 is 1 times 30, 2 times 15, 3 times 10, 5 times 6, and 10 is 1 times 10, 2 times 5. I see that 10 is on both lists. That means that 30 can be divided by 10, and 10 can be divided by 10, giving me 3 over 1, or just plain old 3. Notice you could also see here, you could just do 30 divided by 10 as division. You would also get 3, but I'm just having us practice reducing to simplest form.